Hello, my name's Tate, and welcome back to another Emacspeak C tutorial thingy. So today I wanted to talk about functions. Functions are basically ways of putting your program's code in separate sections. So you can imagine if you have a very complicated program, you would need to have something maybe done twice, maybe done at the start and then at the end again, and it's just not convenient to copy and paste that code. And in fact, it's bad programming practice. You should never copy and paste. It's not really recommended. So I'm going to come up with an example. This is a very simple example, but we're going to use it because it illustrates sort of the reason that you would want to use a function. Using functions in more advanced contexts are usually what you use them for. You usually use them in a more advanced context. But that said, for now, we're just going to stick with an example that might not 100% make sense. You might think, oh, that's a lot of extra work for not a lot of benefit. But once we get into more advanced things like structures, and pointers, if you put all those together, they can really make some very, very interesting functions. So we're going to start out with an example program, and we're going to pretend that we want to get some input from the user and double it. So whatever it is, we want to times it by 2. Okay. So let's say that we're going to get some input from the user. So how are we going to do that? Well, we've talked earlier, I shouldn't say earlier, I've talked before about how to use scanf and all this stuff, so I'm just going to write that code out. This is what we have so far in our file.
/ how to modularize our program. Pound include less than stdio.h greater than int main left paren right paren left brace right brace.
Okay, so I'm going in between the left and right brace here, and we'll set up a number
Int
and we'll call it num.
Space invent to space equals new line.
Okay, and this line is
invent to int num semicolon.
Okay, and then we will print some kind of prompt for the user. Enter a number.
Number apostrophe cap invent to print left paren quotes cap enter a number colon quotes right paren semicolon.
Okay, and then we will scanf %d to get an integer and pass the
cap
address of
invent
num.
to scan left paren quotes %d quotes comma ampersand num right paren semicolon.
Okay, so we're passing the address of num. This is basically, instead of passing the number itself, so instead of saying, here's the number 0 or here's the number 12 or 15, we're saying number is at 123 Main Street. If you want to change it, that's where it is. Simple enough. So that'll load a new number into our num variable. And then finally, we will double this number. So num times equals num, 2.
Invent 2 num asterisk equals 2 semicolon.
So asterisk equals is take the number and times it by 2 and then set it back to that number. So we can type num equals num times 2, but this is just a shorthand. Num times equals 2 is much faster to type. Okay, so num times equals 2, and then we'll printf double is %d \n, and then we will pass num into the printf.
Invent to print left paren quotes cap double is colon %d \n quotes comma num right paren semicolon.
Okay, and then finally we will return
invent
0.
to return 0 semicolon.
Okay,
saving file
so we've saved it. And now what we're going to do is we're going to compile and run this.
/document/describe -tutorials plan -o functions.c.
Okay, and we're going to run functions.
Enter a number colon.
Okay, and let's say we put in the number 10.
Double is colon $20.
Okay, so double is 20. And remember that that $sign at the end when it says dollar, that's just it reading the terminal prompt, which happens to be the $sign. It shouldn't really do that. I'm not sure what's up with it, but anyways, not the point. So this works. There's nothing wrong with it per se. And in fact, it's actually harder to do what we're about to do than it is to do it this way. But it teaches an important lesson. So follow along with me.
Functions.c2, C/*L 98%.
Okay, so we're close to the end of the file. Let's
Indent
go to
to
the beginning.
Beginning of buffer.
Okay, so at the beginning, we're at our comment.
/ how to modularize our program.
Okay, and we have our includes.
Pound include less than stdio.h greater. Int main left parent.
Now, before int main, we're going to add a new function. So we're going to call this int double. You actually can't call it double, so we're going to call it
int
times 2. So times and then the number 2. And then inside the parentheses, we are going to put int x.
Matches int time 2 left parent x.
And then we will open a new brace and close
matches
a new
int
brace.
time 2 left parent int x right parent left brace.
Okay.
Right brace.
So hold on. What is this doing here? What the heck is happening? Okay. So when we do something like printf is a function, and we pass it a constant string. So that's anything surrounded in those quote marks. That's a constant string. It's static. It's unchanging. So therefore constant. We pass it this constant string, and then printf goes and does a bunch of stuff. So we can actually make our own functions like printf. We don't have to make it printf. It can be anything we want. So in this case, we're calling it times 2, or times 2. It says time 2.
Int d space d I m e 2.
Okay, so now our function is called times 2.
Int times 2 left parent int x right parent left brace.
And then there's a blank line.
Right brace.
And then there's a right brace.
Right recap new line.
Okay, so then what are we going to put inside this? Well, you'll notice that we have an int before there. And you'll notice that in our main method, we also have an int, and we return 0. Now for main, the return is actually sent back to the operating system, so Linux or Windows or whatever. It's actually sent back there, and that gives you an idea of whether it ran successfully or it failed or there was some kind of error. But in this case, we can actually return anything. So in this case, oops, sorry, I think I just hit my mic really hard. In this case, let's return x times
x
2.
Indent to return x asterisk 2 semicolon.
X asterisk 2. So what this does is it takes a parameter x. It can be any number, and then it will return x times 2. Okay, so how can we use it? How can we use this times 2 function? Okay, let's go down here.
Right brace. Int main left parent right parent indent to int num semicolon indent to print left parent indent to scan left parent indent to num asterisk equals 2 semicolon.
Okay, so num asterisk equals 2. So instead of doing this,
space new line semi 2 space equals star space mun.
Okay, so I backspaced all of it. We're going to say num equals times 2 parenthesis num parenthesis semicolon.
Num equals times 2 left parent num right parent semicolon.
Now, this actually isn't a clear example, so let's add a second integer here.
Indent to int num semicolon semi comma num.
We're going to call it
mu
num2.
Indent to int num comma num2 semicolon.
So we can actually define multiple variables of the same type in C by just adding a comma between them. Okay, and let's go back down.
Indent to print left indent to scan left indent to num equals times 2 left parent num right parent semicolon.
Okay, and
left parent 2 s e m I t space equals space m u n u m space.
Okay, so we will set num2 equal to times 2 of num. So what this does is it sends num. Num becomes that x. So we have int x in there, which takes an integer. You can take any kind, by the way, so int is not the only one you can take. But we send this int, which we've gotten from user input, we send it to the function. We send it to times 2 saying, here you go, here's a number, and call it x, just during the function, call it x. Whatever else it was called, don't worry about that, just call it x for now. And this will do something called pass by value. So we'll be sending in, for example, last time we ran it, we gave it the number 10. So it will give it the number 10, and then it will do something with that number. it will return 10 times 2. Make sense? And we can change a lot of the other stuff. We're not going to worry about that right now. Okay, and then we're going to change the fact that it's printing num. We're going to change it to printing num2.
Indent to print left paren quotes cap double is colon percent d backslash n quotes comma num right paren semicolon semi right paren cap matches.
Okay, and we're going to add 2.
Media resource colon or 3 dot slash Emacspeak slash cap quit.
If you're ever having any problems, you accidentally open a menu, you don't need to. Control G is quit in Emacs. Okay, so let's read this line.
Indent to print left paren quotes cap double is colon percent d backslash n quotes comma num to right paren semicolon.
Okay, so now we're printing num2.
Cap saving file slash
Okay,
home
so
slash
we've
text
saved that.
tilde slash document slash describe.
Okay, we're going to make the program.
Plan hyphen o functions function.
And we're going to run functions.
Enter a number colon.
Okay, and let's give it the number 15.
Double is colon $30.
Okay, and we got 30. Okay, so it's still working. Great. Now, you might think, wow, that's a lot of extra effort to do exactly the same thing. Don't worry about that yet. Functions have a lot of other interesting uses. Okay, what's another interesting use? Well, for example, what if I wanted to times a number by 2 without creating a new one? So I didn't want to create a new thing. I just wanted to times it by 2. Okay.
Functions.c2 c/*l 93%.
No problem. This can actually be done. So I'm going to go to the start of main.
Hyphen search backward colon. Cap mark saved where search started.
Okay.
Int main left paren right paren left race.
Okay, I can do a reverse search or search by doing Control R or Control S respectively. And then I typed in main and it took me to the start of main. Then I go one up and now I can have new functions here. So what other functions could I have? Well, let's do a void return type. Now void means nothing. So that means if I set num2 equals times 2 something something, if it was a void type, I would actually get an error and it would not let me compile because void, it's nothing. It doesn't return anything. It doesn't give anything back. It just does something. That's all it does. Okay, so we're going to call this PTR times 2. Now PTR stands for pointer, so check out my pointer video if you haven't seen that before. And we will put int asterisk
equals D R N I
int asterisk x
cap matches void PTR times 2 left paren inner asterisk x right paren left race.
Oh, I can't seem to spell right today.
Right rec cap match new line left race space right rec cap matches x space star R N I left paren I N star.
Okay, let's see if this is correct.
Void PTR times 2 left paren int asterisk x right paren left race.
Okay, perfect.
Right race.
And there's
right rec cap matches.
Okay, cool. Okay, well, what can we do with an int asterisk? Now, an int asterisk, of course, is a pointer, as I've discussed before. And we can actually do stuff with the value inside the pointer. Like I said, I've gone over this before. You can dereference a pointer with the asterisk operator. So
X.
asterisk x,
indent to asterisk x.
That actually says, go get me the value in x. Okay. Now, if we do asterisk x times 2.
Indent to asterisk x asterisk 2 semicolon.
Okay. Looks a little, might be a little bit scary. So what it's doing is it's dereferencing x. So it's turning x into its number, and then it's timesing that number by 2. So it's going to 123 Main Street is my classic example, and it's, giving Bob twice the money that he currently has in his bank account. Or I guess in this case it'd be going to his bank account number, and then it's timesing the amount of stuff he has in there by 2. Now we cannot do this with times 2. Okay, the original times 2 function does return x times 2 and it takes an integer. The reason this doesn't work is because in a function where you're not passing a pointer, it actually copies that number and then passes it to the function. It does not pass the direct number, the exact address of the same number. So it can't modify it. So if we did x times 2 inside our original times 2 method, it would do nothing. It would do nothing. It would modify the temporary x variable, and then it would be done. So this one actually can modify the value of x and then finish. So we don't even need a return. A void function is the only type of function that doesn't need any returns. Okay, so let's try this.
Right race.
So we're going to go down.
Int main left paren invent 2 int invent 2 print invent 2 scan left paren invent 2 num2 equals times 2 left paren num right paren semicolon.
Okay, so instead of times 2, we're actually gonna add a new
invent
print
2
statement.
print left paren quotes cap double is colon percent d backslash n quotes comma num2 right paren semicolon.
Okay, we are going to add
invent 2
a second print statement, and we're going to call this original
cap
is
n cap invent 2 print left paren quotes cap original is colon percent d backslash n quotes comma num right paren semicolon.
Okay, so we're going to print num and num2. Okay.
Cap saving file slash home tilde slash document.
Okay, and now we are going to make it.
Plan path 1 warning generated dot dollar.
Yeah, okay. So this will happen sometimes when you're modifying values that are pointers and such. You'll have to dereference them within parentheses. So I'll show you the error.
1 warning tilde asterisk expression function plan hyphen o functions dot c colon 9 colon 6 colon warning colon expression result unused left bracket hyphen 1 used hyphen value right bracket asterisk x asterisk 2 semicolon tilde 1 warning generated dollar.
Okay, and basically what that is it's telling us, hey, just so you know, you're actually not doing anything. So what we're gonna do is we're
functions
just
dot c 2 c slash invent 2 int main left paren right invent 2 asterisk x asterisk 2 semicolon
is we're actually gonna
semi 2 space star x star x space cap matches left paren asterisk x right paren asterisk 2 semicolon.
Okay, we're just gonna surround
Cap
that in
matches
parentheses.
Emacspeak 1.50 Emacspeak.
That's not what I wanted to do.
Cap saving file slash homes.
Okay, there we go. And
right race.
oh, I think it slowed down the speech now.
Enter 250 cap set speech rate to 250 locally.
Okay. So now we've surrounded it in parentheses, and basically what that does is it makes sure that it dereferences the variable first. Instead of trying to take 123 Main Street and doubling it to 246 Main Street, it will now dereference it first and get the original number, so 10 or 20 or 30, and then do something with it. Okay.
Tilde slash document slash describe.
Okay, and we'll make it.
Plan path 1 warning generated dot dollar.
Okay, so it says one warning. It actually still gives us the warning. It should still work, though.
Enter a number, colon.
Okay, so let's give it a number. Let's say 10.
Original is colon. 10 double is colon. $20.
Okay, so it's just a warning. Remember, this isn't an error. And Clang is very picky, whereas GCC tends to let a few things loose unless you give it specific parameters. So Clang is stricter and will let us get away with less. This is totally fine. It's nothing to worry about. Okay. So this works.
Functions.c2 c/*l 41%.
So this works, and this is fine and dandy. Now let's use our new function. So we're actually going to double this twice. So we're going to double it with our times 2, and then we're going to double it with PTR.
Int main left parent right parent invent 2 left parent void PTR times 2 left parent invent right parent main invent 2 invent 2 num2 invent 2 print invent 2.
Okay, so we're putting it in between num2
invent
equals
2 num2 equals times 2 left parent num right parent semicolon
and our printf original.
Invent 2 print left parent quotes cap original is colon %d \n quotes comma num right parent semicolon.
Okay, and in here we're gonna put num2.
We're gonna put
PTR times 2, and then we're gonna put ampersand num2.
Matches the invent 2 ptr times 2 left paren ampersand num2 right paren semicolon.
And you'll know if you've looked at my video on pointers, how this is working and what it's sending and all that.
Saving file /home / document / describe.
Okay, and we're gonna make.
One warning generated.
Okay, and again, it generated a warning. Don't worry too much about that.
Enter a number :
Okay, and let's put in the number 120. 105, let's say.
Original is : 105 double is : $210.
Okay, you'll notice it only did it once. Now, why did it only do it once? I don't know. 1 second. I think I've lost my marbles. Okay, hi, I'm back. I forgot and I'm silly. So, if we dereference a pointer and then say ×2, it's not doing anything with that value. So we have to do times equals 2. So that's my bad. I forgot the equals sign. I see my mess up now. Okay, so we didn't need the parentheses, so don't worry about that. It's a good thing. You should watch this whole video before you actually try to program, hopefully. So this is what the line looks like now.
Functions dot invent 2 asterisk x asterisk equals 2 semicolon.
So it's asterisk x
star x space star equals space 2 semi.
Okay. So that is the single line in PTR ×2, and now we are going to run it. So we'll switch back here.
Document described
and we're gonna make
-o functions dot c.
And we're gonna run functions.
Enter a number :
and we're gonna do 105.
Original is : 105 double is : $420.
Okay, now obviously this is not double, this is quadruple, but that's not the point. The point is that we times our number by 2 twice in 2 different ways. So first of all, we sent a number into a function and set that equal to a new number. So we did
functions
that.
C2 C / int invent 2 print left paren invent 2 scan left paren invent 2 num2 equals times 2 left paren num right paren semicolon.
Okay, that's where we did that. We set num2 equal to function times 2, and we sent it num. And then secondly, we actually passed a pointer of num2 and updated it from within inside the function.
Invent 2 ptr times 2 left paren ampersand num2 right paren semicolon.
Okay, and then we print original.
Invent 2 print left paren quotes cap. Original is : invent 2 print left paren quotes cap. Double is : %v \n quotes comma num2 right paren semicolon.
Okay, I'm actually gonna replace double
D
here.
O U B L E space E L B U O D.
Okay, quadruple. I don't know if I spelled that right, but
invent 2 print left paren quotes cap. Quadruple is : %v \n quotes comma num2 right paren semicolon cap. Saving file /home.
Okay. So the important thing to know is that functions can return things or nothing, and they can take arguments, or sometimes they take no arguments. So a lot of times the help function of a program will be one function somewhere higher up before main. Excuse me. And then anytime in main, they can call help, the help function, with no parameters. So that would be help left parenthesis, right parenthesis. In fact, let's have an example of that. So we could have a void function like prompt.
Invent 2 int main left paren right paren right.
Okay. So let's have a void function prompt.
Cap match prompt.
And then we could have printf enter
cap
a number.
Number cap invent 2 cap matches void prompt left paren right paren left race.
Okay, so the 3 lines look like this.
Invent 2 void prompt left paren right paren left race. Invent 2 print left paren quotes cap enter a number : quotes right paren semicolon right race.
Okay, so we now have that function.
Invent 2 print left paren quotes cap enter a number : quotes right paren semicolon. Invent 2 print left paren quotes cap semi enter a number : right paren quote.
Okay, shh, quiet. Sometimes Emacs talks a little bit more than it should. So now we can actually replace our printf enter a number with prompt.
Cap invent 2 prompt left paren right paren semicolon cap saving file /home /text ~document /describe.
And then we are going to make
-o functions.c.
And then we're going to run.
Functions enter a number : Original is colon 210 quadruple is colon $840.
Okay, so in this case, we have a function which returns nothing and takes no arguments. You can have as many arguments as you want or none in a function. So we can just keep adding commas. So just like when we're calling a function and we add more parameters like printf. So printf, we have in quotes, original is %d\n. Then we have a comma and then num. Okay, so we can actually pass more parameters. So let's say, for example, that we don't want to times by 2. Timesing by 2 is lame. What if we want to times by any number? So let's do that. We're going to add a new function.
Functions.c to c slash asterisk l 59%, invent to int num, comma, int main, left paren right ray.
Okay, so we will do another void. We're going to use pointers again. Times x. We're going to call it times x. And it's going to take an int x,
space.
an int asterisk x, so an
comma,
int pointer x, and an int n.
Cap matches void times left paren n. Cap matches void times left paren int asterisk x, comma, int n right paren left race.
Okay, so then inside this times x function, we will do asterisk x times equals n.
Invent to asterisk x asterisk equals n semicolon.
Okay, so asterisk x is dereference x, get me the value of x. Times equals is times the number by this next number, and then n is how many times we want to times it by. Okay, so this does it all within one beautiful line, and now we can call this function from other places in our program. So this is times x. Let's go forward and let's times by 10 somewhere else.
Right int may invent to int num invent to prompt left paren right invent to scan left invent to num to equals times to invent to ptr times to left paren ampersand.
Okay, so we're putting it right after ptr times 2.
Invent to ptr times to left paren ampersand num to right paren semicolon.
And
invent to print left paren quotes cap original is colon %d backslash n quotes comma num right paren semicolon.
So we're gonna do times x, and we will pass ampersand num2.
Num2.
And we will pass, let's say, 10.
Cap invent to times left paren ampersand num2 comma 10 right paren semicolon.
Okay, so we're passing the address of num2, which is what we can dereference, so we can set it from inside the function. And then 10 is how much we want to times it by, and this will hopefully return us, excuse me again, this will return us a value of 10 times 4 times. So it'll times by 2, then times by 10. So we're going to save.
Saving file /home /text /c-x.
Oops. How do I stop that?
C-x C-G is undefined.
Okay. Oops. All right. And we're going to switch windows.
/document /describe.
And we're going to make
/o functions.c.
And we're going to run functions.
Enter a number colon.
Okay. And let's do 105 again. So remember, before we got 420. Now we should get 4,200.
Original is colon 105 quadruple is colon $4,200.
Okay, so now times x is taking that pointer of num2 and that multiplier, which is 10, and it's doing stuff all within inside the function to be able to produce a number which is 10 times the size. Now, here's the great things about functions, is that functions can call other functions. You noticed that our prompt function was able to call printf. Well, we can actually make a function which will do all three of these lines. Num2 equals times 2 num. I'll just read the 3 lines that we're going to replace with one function.
Function invent to num2 equals times 2 left paren num right paren semicolon. Invent to ptr times 2 left paren ampersand num2 right paren semicolon. Invent to times left paren ampersand num2 comma 10 right paren semicolon.
Okay, we can replace all of these, with a one beautiful function. Well, how are we going to do that? I will show you.
Invent to int main left paren right ray.
Okay, we are going to make a void function.
Void.
So void, and we're going to call this the math.
HDA
underscore math, and we are going to take an int
UN,
orig for original number,
orig,
int asterisk
int,
for new number. We're going to call it new n.
new,
And then we are going to have a final one, which is int multi for multiplier.
cap matches void the underscore math left paren, multi,
Okay.
cap matches void right rec cap matches,
Okay, so these are the this is the starting line for our new void function. This has 3 parameters this time.
void the underscore math left paren int orig, int asterisk new, int multi right paren left brace.
Okay, and then we've
Right
got our
brace.
right brace. Okay, so inside it, we will call all 3 of our previous functions that we have defined. So first of all, we will say asterisk asterisk NEWN, new n for new number, equals times 2 of orig.
Cap matches invent 2 asterisk new equals times 2 left paren orig right paren semicolon.
Okay, then we will say times 2
SEMIT
PTR times 2 NEWN.
cap invent 2 PTR times 2 left paren new right paren semicolon.
Now you might be asking, okay, well, why are you passing new n? Why are you passing that directly to PTR times 2 without doing an ampersand? Well, I'll tell you why. It's because new n is actually already a pointer. So it's already 123 Main Street. It's already the bank account number. It's already the social insurance number, whatever you want to think of it as. So we don't actually need to ask for what is the address. You don't want the address of the address. I think you can do that, but don't worry about it. Okay, so it's already a pointer. We're just passing it along. Okay, perfect. And then finally we will times x, new n,
new,
and multi for multiplier.
cap invent 2 times left paren new, multi right paren semicolon.
Okay, and all of this will do the same thing as those 3 lines we had down there. So let's scroll
right
down.
int may invent 2 int num, invent 2 prompt left paren right invent 2 scan left paren invent 2 num 2 equals invent 2 PTR times 2 left invent 2 times left paren ampersand num 2 10 right paren semicolon semi right paren 0 1 space 2 M U N space new line.
Okay, so we've cleared out the line. It now has nothing in it. As you can see, I hit Control E L and it says nothing, so there's nothing here. Okay, so what do we write here? All we write is the underscore math, and the original is of course num.
Num.
The new n pointer is ampersand
NY B
num2,
num2,
and then finally the multiplier is
9. Cap
10.
matches the invent 2 the underscore math left paren num, ampersand num2, 10 right paren semicolon.
Okay, and this will do exactly the same thing as we've been doing all along.
Cap saving file /home /text tilde /document /describe.
Okay, we're going to make this,
/o functions
and we're going to run functions.
Enter a number colon.
Okay, and we're going to run 105 again, and this should give us, actually we're going to run 210. And this should give us the number 8,400.
Original is colon 210 quadruple is colon $8,400.
Not bad, right? So this is how you can imagine things getting kind of complicated when you're passing references to pointers, and then the pointers are being passed to new functions which take pointers, and it gets really complicated. This is why C programming is considered low level. I wouldn't say that's a good way to characterize it, but it's dealing with very raw data structures, and you can imagine someone accidentally doing something to a pointer, accidentally sending it somewhere wrong, and the value ending up being completely different or incorrect when it comes out of a function, which called another function, which called another function, which called a group of functions. You can absolutely imagine some pointer getting messed up in the process. So again, this is why C is considered I guess a dangerous language would be the right word. If you're good at it, it's not too dangerous. But yeah, it's hard to be good at C, and this is why. It's because of how many pointers you can pass around. Um, so that's it for sort of basic functions and pointers in functions. One of the more advanced things you can do with functions is send structures through them. So structures are data that are sort of packed together. So, for example, a person might have an age, a name, a social security number, a bank account balance, and maybe a GPA. And all those things are different types, right? My name can't be represented in a number, and neither can my GPA in a string. I mean, unless the string is 2.2. I hope my GPA is not that low, but I'm going to find out. Probably 2.9. Fun fact, my GPA, last time I checked it, was 3.14. So my GPA was pi. That's a fun fact for you. I know none of you care. Okay. That's the basic of it. Structures, I'm going to try doing a video on structures at some point. And yeah, hopefully this made sense. Download the resources in the description and follow along. And then I'll have more videos coming soon. Bye-bye.